Hi, I'm Chris, and we're taking a look at a physics problem here dealing with momentum. So we're going to look at a situation where we have a collision occur, and with momentum there are three types of collisions. Elastic, which basically means the two objects are going to bounce right off of each other and no kinetic energy will be lost. And then inelastic, which means that the two objects will bounce off of each other but some kinetic energy will be lost. And totally inelastic, which is the situation we're going to work with here, and that's where the two objects collide together but then stick together after the collision. And so here in this word problem, it's a word problem where it describes two hockey pucks traveling in different directions, and one has a piece of gum affixed to it which causes the two pucks to stick together after the collision. So after they collide and stick together, we want to find out what happens to those two pucks that are now stuck together. Which way do they move post-collision? So let's take a look at how we're going to calculate this. First, you'll notice that they give us values here for the mass of the first puck. They tell us it's 8 kilograms and it's moving 15 centimeters per second to the east. The first thing I would recommend doing here is converting this units-wise. Standard units for physics, rather than centimeters per second, are going to be meters per second. So we want to make that conversion from 15 centimeters per second to 0.15 meters per second. That's important there. Same thing for this other puck. Numerically, we're going to have to do a conversion here, but this is a concept idea that's really important before we do the numerical conversion. If you notice the velocity of this second puck, it's to the left. If we assign our velocity to the right to be a positive value, if we call the right our positive direction, then that means the left will be a negative direction. So you want to make sure that you include a negative value. It's going to impact your calculations significantly. So that's first and foremost something that we want to do when beginning our calculation here before we come to the point where we can make the conversion. Now, we convert this 25 centimeters per second will be 0.25 meters per second. So we'll have a velocity for this second puck of 0.25 meters per second. Now we can plug these values into our equation for conservation of momentum to calculate the final velocity after these two pucks collide and stick together and find out which direction they go and how fast they're going. So for that, hopefully if you are dealing with momentum, momentum is mass times velocity. And hopefully if you're dealing with collisions, you've seen conservation of momentum, which looks like this. m1 v1 initial plus m2 v2 final equals, so this is before the collision. Oops, I meant to put initial here. Excuse me. So this is before the collision. We have our initial velocities. And then after the collision, if the two objects combine together and stick together, then their masses will also be combined. So afterwards, we're going to have one big mass, which is the sum of the two smaller ones, and one final velocity. So that big object of the two masses is going to be moving in a certain direction. And this value for final velocity is the one we don't know a value for. We actually, in our problem, can plug in values for all the rest. So let's take those velocity conversions that we just did and the masses that we were given and plug it in and see what we come up with. So here mass 1 is 8. Your initial velocity is 0.15. Mass 2 is 2 kilograms. Your initial velocity of that second mass is negative 0.25. Make sure to include the sign. Remember, velocity is a vector. Direction does matter, which means the sign matters. We take the sum of the masses, because again, the two objects are sticking together. Mass 1 plus mass 2, 8 plus 2 will give us 10. I'll write it in here as 8 plus 2, so we see where that number comes from. And then we're going to go ahead and add these values together and simplify to find out what our final velocity is. 8 times 0.15 will be 1.2. 2 times negative 0.25 will be a negative 0.5. Equals 10 times Vf. When we add these, 1.2 minus 0.5 will give us 0.7. Equals 10 times our final velocity. We divide both sides by 10. That will give us 0.07 meters per second for our final velocity. Now there are two important things for us to notice on this. First of all, this is in meters per second if in the problem, if it's asking for you to convert back into the original units, then you can convert meters to second into centimeters per second by multiplying by 100. So 0.07 meters per second would be equivalent to a final velocity, actually let me just write it in down here, a final velocity of 7 meters per second. And then also the fact that this came out to be, oops, I meant centimeters per second. The fact that this came out to be a positive value, it's a positive 7 centimeters per second, that also tells you direction. Remember, at the beginning we said to the right was the positive direction, to the left was the negative. So that means after these two hockey pucks collide together, they will continue moving in the positive direction, which is towards the right here, at 7 centimeters per second, or 0.07 meters per second, for your final velocity of that object after the collision has taken place. For more, please feel free to watch our other videos, and thanks for watching.